So we're going to start section 4.7, and I'm going to make a executive decision. We're just going to do 5 through 11 odds for homework. We're going to skip 1, 2, 3, and 4. 1, 2, 3, and 4 are kind of introducing the theory of this section, and I think I can do that theory while we do the problems to make the video a little bit tighter. Each problem, 5, 6, 7, 8, 9, 10, and 11, has a part A and a part B. The instructions are exactly the same for every problem we're going to do. Specifically, we're going to be given a function that's either a square root in part A or a cubed root if it's the corresponding part B problem. We're going to make a table of values. We're going to sketch a graph. I'm going to write the domain of the graph using interval notation, which is a skill we had earlier this semester. It's a skill that comes up a lot in higher classes, so it's a good one to review. And then I'm going to write the range in interval notation. Every square root graph that we're going to do, they're going to look more or less exactly the same. They're going to look, remarkably similar. And all the cube roots graphs look like cube roots, square roots look like square roots. We'll do the 4 square roots, the 4 part A's first. I'll do 6A, 8A, 10A, and 12A. And then we'll come back, I'll do a part B. We'll do 6B, 8B, 10B. Oh, I guess I'm only going to do 3 problems. I'm going to do 6, 8, and 10. I didn't make a 12 for me, but 3 should be enough. So, part of the problem when students are asked to graph a function that they've never graphed before, like graphing f of x equals the square root of x minus 3, it's hard for a student that's never graphed to know a good table. If you can get a good mix of values in your x column, then the points that are created when you make the table will really help you understand what the graph looks like. If you get cruddy x's, you might miss the key features of the graph. For square root graphs, I'm going to get 7 points, 7 values in my x column. And what I'm going to do is solve 7 different equations. I'm going to set the radicand equal to 16. Which is a 4 squared. I'm going to set the radicand equal to 9, which is 3 squared. I'm going to set the radicand equal to 4, which is 2 squared. I'm going to set the radicand equal to 1, which is 1 squared. I'm going to set the radicand equal to 0, which is 0 squared. I'm going to set the radicand equal to -1, which really isn't anything squared, but it's kind of the opposite of positive 1. And I'm going to set the radicand equal to -4, which is the opposite of 4. Solve each one of these, take each one of these numbers and throw them in my x column. Those are the numbers I'm going to use to find y's. They're going to make me get a good graph. So the first bit of work, when I set x minus 3 equal to 16 and add 3 to both sides, I'm going to get 19 in my x column. When I set x minus 3 equal to 9, I'm going to plus 3 to both sides and get x equal to 12. When I set x minus 3 equal to 4, I'm going to plus 3 to both sides and get x equal to 7. When I set x minus 3 equal to 1, I plus 3 to both sides and get x equal to 4 for my x column. Setting x minus 3 equal to 0, I get x equals 3 for my x column. Setting x minus 3 equal to -1 and adding 3 to both sides, I get x equal to positive 2 for my x column. And lastly, setting x minus 3 equal to -4, the opposite of 1, the opposite of 4, I go plus 3, and I get x equal to negative 1. So the numbers I'm going to set equal to are 16, 9, 4, 1, 0. The opposite of 1 is negative 1. The opposite of 4 is negative 4. This is not a creative list. This is 4 squared, 3 squared, 2 squared, 1 squared, 0 squared, and then opposites. Now for each x, I'm going to get a y. We could call that y f of x because the problem is written in function notation. So when x equals to 19, I'm going to plug 19 into this equation and go f of 19 equals the square root of 19 minus 3. I'll use my calculator so I don't have to think, but I know what it comes out to be. The y is going to be 4. So I'm going to make this a point. I don't need to write it as a point, but that's kind of what I've done right now. It is what I've done. I've created the point 19 comma 4. So on my graph, I'll find 19 on the x-axis and go up 1, 2, 3, 4. There's my point 19, 4. That's one of the points that I'm going to graph. This is going to be a graph that extends beyond what I'm going to write because I could have made bigger numbers, and we'll get to that in a bit, but the graph doesn't end where my points end on the right-hand side. When x equals to 12, I'm going to do f of 12, which is the square root of 12 minus 3. It's going to give me 3. So next I'm going to plot the point x equal 12, y equal to 3. Then I'm going to plug in 7 and get f of 7 is the square root of 7 minus 3, which is 2. That's going to give me the point 72. I don't have 7 marked, but I could guesstimate it. Then I'm going to plug in 4, get the square root of 4 minus 3, get 1. So I'm going to get the point 41. Then plug in x equal 3, get f of 3 is the square root of 3 minus 3, and get 0. So I'll plot the point 3, 0, estimate it. Now I'm going to plug in 2, and bad things are going to happen. I get the square root of 2 minus 3. If I did the math in my head, that would be the square root of negative 1. And square roots with negative numbers aren't real numbers. I get kind of errors or no solutions. That's going to be no point on my graph. This right here is no solution or not a real number. I'm not going to get a point that has an x-coordinate of 2. When I plug in negative 1, I get f of negative 1 equals the square root of negative 1 minus 3, square root of negative 1 minus 3. Same thing happens. I get another error, so I'm not going to get a point on the graph here. So I've gotten all the points I can get. Hopefully I can start to guesstimate what the graph is going to look like. It turns out this is going to be the hard start of my graph. I'm not going to get a point to the left of that 3, 0 because all of them, if you plug the number in for x, the algebra would produce a negative under the radical, and that's an imaginary number. It doesn't show up on a graph with real numbers. So now I'm just going to connect the points the best I can. They have a really hard start right there. And I'm going to put an arrow this way because I could have put bigger numbers in. The graph doesn't really end. So I've done most of what I want to do. I've made my table. I've sketched a graph. Now I'm going to find the domain and the range. In order to do the domain, I have to know where this graph extends to horizontally. And this graph is going to go up and to the right forever it's going to extend to the far right edge of the x-axis. So when I go to find my domain, remember we try to find the left edge of the graph and the right edge of the graph, and we pick off the x-coordinates at the left edge of the graph and the right edge of the graph. So I have my left edge and my right edge, and the x-coordinates are 3 and infinity. 3 is marked with a closed circle. It's going to get a square bracket. So in for my domain, it's going to start at 3 and end at infinity. When I go to find my range, I search out the bottom and the top of this graph, and I pick out y's. The bottom of the graph is down here. This graph, although it takes its time, eventually the top of the graph goes up to the top of the y-axis. The farther out I go to the right, the higher the graph gets. Eventually, it's going to make it up to the top of my graph, regardless of how high I write that line. The further I go right, my graph will always go above it. So for my range, I'm picking off y's. The y point at the bottom of the graph has a y coordinate of 0, marked it with a closed circle so I get a 0 to start my range. The y coordinate of the top of the y-axis where the graph ends is infinity. Infinities always get square brackets. That's everything for 5a. Your 6a should work remarkably similarly. 8 and 10 aren't going to be remarkably different, but a little. So to get started, I want to get my table to start. So I'm going to go x plus 2 equals 16, x plus 2 equal 9, x plus 2 equal to 4, x plus 2 equal to 1, x plus 2 equal to 0, x plus 2 equal to negative 1, x plus 2 equal to negative 4, to help get the values that go in my x column. My y column I could call y, or I could call it f of x. Similarly, my y-axis, I could call the y-axis or the f of x axis. Let me solve these real quickly. First number in my x column I'm going to plug is 14. Second number in my x column is going to be 7. Third number in my x column is going to be 2. Fourth number in my x column is going to be negative 1. Fifth number in my x column is going to be negative 3. Last number in my x column is going to be negative 6. Now for each x I'll get a y. First x, I'm going to do f of 14 equals the square root of 14 plus 2. That's going to give me 4. So if I have room, I'm going to plot the point 14, 4, and I gave myself room. If you open up the tab that says, I haven't created it yet, but I think it's going to say lecture notes, you can get these blank graphs if you need them. They're included. Next point, I'm going to do the square root of 7 plus 2, and just do everything on my calculator to save some work. So my second point is going to be 7, 3. So estimate 7 and go up 3. Then I'm going to do the square root of 2 plus 2 and get 2. I'm not writing the points down anymore. I'm just going to plot these points as I discover them. And then I'm going to do negative 1 in for x and do the square root of negative 1 plus 2, which is 1. So I get negative 1, positive 1. estimate -1, know where positive 1's at, and then the square root of -3 plus 2, error, or no solution. If I plugged that number in and did f of -3 is the square root of -3 plus 2, I'd wind up taking the square root of a negative number, and that's not a real number. And then the last one, square root of -6 plus 2, same, no solution. So, I didn't do this one. I skipped over that. Let me get that back in there. I was missing a point. I missed this guy. X plus 2 equal to 0. I forgot to plug in -2, and that's a hugely important point. It's actually the start of my graph. The point when you get the x plus whatever, the radicand equal to 0 is the most important point, and I missed it. So let me get that point in there. Do the square root of -2 plus 2. It's the start of the graph. I did everything but the start. So the -2, 0 is the last point that I'm plotting. Notice I didn't write so many numbers this time. It's okay, you don't need to write numbers, but you might want to write numbers at the start of the graph. So now I'm going to just connect these. This graph, again, is going to look pretty similar to my last graph, and it's going to continue to the right. I could plug numbers bigger than 14 in and not get an error, but it's not going to go off to the left because numbers less than -6 will still give me errors. So there's my make a table, sketch a graph. Now I'm going to read off the domain and the range. And for our class, for all square roots, every square root we're about to graph, the domain is going to be square bracket, some number, comma, infinity. It's possible to have square roots that don't have this for their domain, but all the ones we are going to do are going to have that for their domain. Similarly, all the square roots we're going to graph, when we're graphing the square roots, are going to look similar. They're going to be some number, comma, infinity. This is because the graph will have a bottom and a left edge, but not a top nor a right edge. When I go to do the domain, I look for the left edge, and there really isn't a right edge. This graph's going to go forever up and to the right, and the right edge of the x-axis is infinity. So for my domain, the graph starts at the point -2, 0. When I go to do my domain, I need the x's. So I'm going to say the domain is square bracket -2, comma, infinity. When I go to do my range, I need the bottom and the top. And this graph eventually gets up to any horizontal line that I would draw. It's eventually going to go beyond it. It's going to go to the top of the y-axis, which has a y-coordinate of infinity. So the range for this guy, the value that I need for the range on the bottom is the y. So the range is going to be 0 and then to infinity, because the graph keeps going up and never stops going up. One more square root graph, and then we'll pause the video and do cube root graphs. So for number 10a, even though it has a number outside the radical, that's going to impact my y's. It's not going to impact my x's in my x column. I'm going to go x minus 2 equals 16. X minus 2 equal to 9. X minus 2 equal to 4. X minus 2 equal to 1. X minus 2 equal to 0. X minus 2 equal to -1. And x minus 2 equal to -4 to get the numbers for my x column. My first x, I'm going to add 2 to both sides and get 18. My second x, I add 2 to both sides and get 11. You could do these in your head, don't show the algebra. The next one, I'm going to add 2 to both sides and get x equal to 6. And then add 2 to both sides and get x equal to 3. Add 2 to both sides and get x equal to 2. That's going to be the start of the graph. Add 2 to both sides and get x equal to 1. That's going to be an error. Add 2 to both sides and get x equal to -2. That's going to be an error. Let me do all the y's now, just on my calculator. First y, square root of 18 minus 2, arrow out of the square root, and then -1. My first y is going to be 3. Let me just do all the y's before I plot. I'm going to use my reverse arrow back to change this to square root of 18 minus 11. Whoops, I'm going to do this wrong if I do that. I need to make this the square root of 11 minus 2. I needed to change the 18 to 11, not change the -2. So my next y is going to be 2. Now I'm going to go back and change the 11 to 6 and get 1. Then I'm going to go back and change the 6 to 3, just taking the numbers in my x column, and get 0. Go back and change the 3 to 2, just going down my x column, and get -1. And then my errors. Go back and change the 2 to 1 and get error, or no solution. I'm not going to get a graph there. And then I wonder if I could just go back, and go back and change the 1 to -2, and I'll get another error. So those are my points. Now I'm going to make a table. I have my table. Those are the points. Now I'm going to sketch a graph. So 18, 3, 11, 2, 6, 1, 3, 0, 2, -1. That's the important point. This graph sneaks below the x-axis because of that -1 that's not part of the radical. Let me draw my graph. This is the hard start of the graph. And it goes just like that, up and to the right forever. So I made my table, I sketched my graph. Now I'm going to find the domain. I have this hard left edge right here. That's going to be the start for my domain. That's my left edge. The x coordinate at the left edge is the +2. There isn't a right edge. The right edge, can't even spell right with that room. The right edge is going to go to infinity because it goes to the far right edge of the x-axis, which has a coordinate of infinity. Round brackets on the infinities. I'll do my bottom and top for the range. My bottom is that point to -1. My top is the top of the y-axis because it goes up and to the right forever. The top of the graph is going to be infinity. There is no real top. It's always, if I draw a horizontal line, if I go out far enough, it'll jump that horizontal line. So to start my range, I need the y-coordinate at the bottom, square bracketed because it's a point on the graph, and the end my range, I get the infinity. So you should be able to do 5, 7, 9, and 11 part A. They shouldn't feel any different. Just set the tables up the same way and should be good. Then we'll do a part B, a part 2 of this and do all the cube roots. I don't know if they're easier or hard, they're just different.